Hey guys, so today I'll be introducing you to Pandas, which is a popular Python library used to analyze data. And for those of you who are unfamiliar with Python, it is a popular programming language that is fairly simple to use. Now, in this video, you'll be learning the basic concepts needed to perform a simple analysis on datasets. And to learn these concepts, we're going to be playing around with a Pokemon dataset. And then later on, we're going to make a simple project using the COVID-19 dataset. And hopefully by the end of this video, you guys will be able to explore the varying patterns in the COVID-19 dataset and maybe discover something to prevent the spread of COVID-19. So for this video, you won't need any prior knowledge in programming, and I'll try my best to run you through the very fundamentals. For those of you who are more experienced, please feel free to skip ahead. And if I'm going too slow, you guys can definitely just speed up the video to make sure I'm talking faster. All right, so let's get started. So for those of you who don't have Python, you should have this installed. Just do a quick search, Python downloads, and make sure you come up to this screen. It should be the first screen that pops up. If not, just click downloads. And then you want to download the latest version. So that's that. Moving on, you also want to download PyCharm. And PyCharm is where we're going to be coding. And if you already have an IDE that's not PyCharm, that's fine. You can use that as well. But in this video, I'll be using PyCharm. And when you're installing PyCharm, make sure you get the community version, as this one's free and the other one's not. And the last thing you want to download is this dataset called Pokemon with Stats. And this will be on this website called Kaggle. In order to download this dataset, you will want to make an account, and it's fairly easy to do so. There's honestly no hassle, should be fine. Once you do that, you want to download it. I'm not going to download it because I already have it downloaded. So before we actually start coding, you want to make a folder. So over here, I'm going to go into my folder over here, and I'm going to make a new folder for this project. Where is it? Okay. And I'm going to name it Pandas. So once you've made a folder, you want to go back to your downloads. And you want to extract your Pokemon dataset file because it's compressed. And you want to extract it to the folder you just created. So it already led to me here. So I'm going to extract, select folder, extract. There, it's been extracted. And I'm just going to click on the file to double check. That is the file that we want. And yes, it is. So now we're done with the setup essentially for the beginning. And we're not going to get to coding just yet. I'm just going to briefly explain the concepts that you'll need, and then we can start coding. Okay, so I'm just going to introduce you to the concept of variables, and variables are essentially your containers that store information. For instance, you can have a variable name called first name and have it store the name Eric. Now, when naming your variables, there is a standard convention that programmers tend to use, and it's called camel casing. And camel casing basically means that your first letter is always lowercase, and any following word should begin with a capital. So here we have F, which is lowercase, and N, which is uppercase, because name is the following word. So therefore it has been uppercased. So let's just create a new variable name just to make sure you guys are following along. So let's say I have first name bad as my variable name. F would be lowercase, N would be uppercase, and B would also be uppercase. So following that convention, your variable name can literally be anything you want, as long as it does not contain a number or any special characters, such as a space or a dollar sign and whatnot. So this variable name over here, number 1, would not be valid. So now you just learned a little bit how to name variables and what variables are. We're just going to talk about what they can store. So variables can store these types called strings, integers, and doubles. There's also other different types of values, but we'll just focus on these three for now. So strings. what strings are essentially, they're just text or a collection of letters or words. For example, you can have a hair color, and the hair color can be blonde. And when you write this into the program, you set hair color equals to blonde. To show the program that the variable is a string, you want to put it under two quotation marks, or in between two quotation marks. And what this tells the program is that, hey, look, I'm declaring a string over here. So yeah, that's basically all you need to know about strings. Moving on, we have integers. And integers are basically just whole numbers that can be positive or negative, meaning no decimals, just whole numbers. So we can have a variable representing our age, and we can set that to 18. And that's valid because that's a whole number, and it's an integer. Moving on, we have doubles, and doubles are your decimals. So it can be pi, it can be 1.26 and whatnot. An example for a double could be the temperature, and the temperature could be 23.6. So yeah, this is pretty much your introduction to programming. I know it was very, very brief, but I think this is all you'll need to know in terms of what we'll be doing today. And if you want to learn more, feel free to look for resources online, such as Geeks for Geeks. That's a great resource for learning computer science on your own. So moving on, we're gonna go a little bit deeper into Pandas, and we're just gonna talk about how they store data. And what Pandas uses is that it uses a data frame. And a data frame is a 2D structure that stores data of any type, meaning it can store an integer, a double, or even a string. And I know this may sound very abstract, so here's an example of a data frame. Now, looking here, you can see that we have the name of an individual, the eye color of an individual, and the age. And the cool thing about data frames is that since they're 2D, they can be accessed with essentially 2 dimensions, meaning you can use the rows and columns of this chart to access the data. So like the name of the person or eye color, age. And there's essentially what some people would call a formula to access data. So basically all you need to do is use the row number and the column number. So let's say I want to get Rachel's age, and we can see that it's 6. Now, according to the labels I have on this chart, we can see that Rachel is located on the second row, and that's denoted by 1. And then we have the column age, which is denoted with the number 2. So with that, we can say that Rachel's age is located in 2, 2. And you might be looking at me and you might ask, okay, why is the second row denoted with 1? Because second usually refers to 2. Well, in programming, numbers tend to start at 0 rather than 1. So like the first row and first column would be denoted with the number 0 instead of 1. I don't know why, but that's just how it is. So yeah, this is how we access data within a data frame. So let's just run through one more example. You can do it in your head. Let's say we want to get Eric's eye color, which is black over here. So what would that location be? All right, so the location would be 1. Sorry, my bad. No, it would be 0, 1. And one other thing to note is that on the screen, you can see that the location is actually enclosed with 2 square brackets. And that's how we usually access data within a structure. And we call this indexing. So whenever you're trying to access data within a structure, you would use the square brackets to indicate that you're doing that. So hopefully you guys wrapped your head around this concept of data frames and accessing the data, as we're going to start coding and we're going to apply this concept. Okay, so now we can start coding. So to begin, you just want to open up PyCharm, Once you've opened it up, you want to go to File, New Project, and then within this window over here, you want to click on the folder icon and navigate to the folder that we created earlier where we saved our Pokemon dataset. So once you're done that, you'll have this window up over here. Just right click, click New, and then click New Python file. And then you can name it whatever you want. I named it Pokemon. And then now we can type in our first line of code. So our first line is going to be import pandas as PD. Now what this is going to do is that it's going to import the pandas library, which will allow our folder to, or allow our file to use it. And then it stores it in the letters PD. So whenever I want to use something from the pandas library, I have to type out PD. So the first thing we're going to do is that we're going to store our Pokemon dataset into a variable. So I'm going to make a variable called df, which stands for data frame, and I'm going to read our Pokemon dataset. So what you want to do is call read CV, then you're going to type in the file name over here in quotation marks, which indicates that it's a string, and this will essentially store everything in our Pokemon dataset in this variable over here. Now the reason why we use CSV is because our file format is comma separated values, and what that actually means is that, well, it's given in its name, but what it means is that each value is separated by a comma. And if you look at our data set, this is what it looks like in a notepad. Now, if you want to see what our data set looks like, we can just use a print statement, which essentially just outputs the value of the variable into our console. If I run our console over here, it'll give us our data set. Now, for those of you who are having trouble running the console, you just click on run over here and click run Pokemon, or run whatever file name you put. Now, the interesting thing about the print is that it also tells us the dimensions of our data set. And we can see that it's 800 columns by 800 rows by 13 columns. But we only have 6 columns here. Now, that's not really a big problem. I'm just going to be picky here, and I want to see all 13 columns. So to do that, you can just do this. So we're going to increase the width of our console, because right now I think it's restricted, so it's not letting us see more than 6 columns. And then I'm going to set our maximum amount of columns to be seen to 13, because that's the amount of columns that we have anyways. So if I rerun the program, boom, there we go. We have all of our stats here. So yeah, now we're gonna delve a little bit deeper into the Panda methods. So next we're gonna look at the head method. And what the head method does is that it takes a portion of the data set and basically outputs it. So for example, if I use .head and I put in the number 3 here, what this will do is that it'll take the first 3 rows and delete everything else essentially. So let's see, if I run this, there we go, we got the first 3 rows. And this is useful when you just want to analyze like a portion of the data. For example, in this case, let's just say I just wanted to analyze the evolutions of Bulbasaur, and here we go, we got it. Now, one thing to notice is that you can also call the head method without assigning a number, and this will just give it a default value of 5, meaning 5 rows will be printed. Yep, 0, 1, 2, 3, 4, 5 rows. So yeah, that's just the head method. Moving on, we're gonna get into these indexing methods, meaning just accessing values within the data frame. So there are 2 methods that are going to be present. One's going to be called loc, and another one's going to be called iloc. So we're going to look into loc first. So what loc does is that it allows us to access the data frame, but it uses the labels rather than the column numbers and row numbers that that I introduced earlier within the introduction. So prior to this, we had like row number 0, 1, 2, 3, 4, and then column number 0, 1, 2, 3, 4. What loc does is that it allows us to reference these columns and rows using their labels. So for example, the first column is denoted with the pound symbol. The second column is denoted by name, but the rows still stay the same because this is the label for the rows. So let's run into an example. Let's say I want to get Bulbasaur. So as you can see, we know Bulbasaur is in the 0th row, or the first row, and it's denoted with the label 0. So I'm going to type in 0, and we know it's in the column names. So I'm going to type in names. And once again, I put names in quotation marks because it is a string. So if I did this right, I should get Bulbasaur. Ooh, I got an error. Let's see why I have an error. Now I get an error because no attribute loc. Oh, my bad. I put down PD. I meant to put down DF. The reason why PD doesn't work is because the Pandas library, you can't call loc on a Pandas library. You have to call it on a data frame or the data structure. So yeah, that's why I got the error over there. And there we go. We got Bulbasaur. So that's cool. One other thing about loc is that you can also get like the whole row of a data frame. So let's say I wanted to get the whole row of Bulbasaur. I just don't need to specify the column. I could just specify the row, and then boom. There we go. What a beauty. See? We get all of the stats of Bulbasaur. That's pretty cool. So now let's move into iloc. What iloc is what we referenced earlier. So rather than using the labels, it uses the numbers. So this would be the first column. It would be 0. This would be 1, 2, 3. So let's go through the same example. Let's say I want a Bulbasaur. Let's see how it changes. It's in the first row denoted by 0. So I put in 0. And then it's in the second column denoted by 1. So if I print this, I should get Bulbasaur. And there we go. We get Bulbasaur. So that's really cool. And since we have like the generals down, the general basics down, we're going to go into a little bit more advanced indexing techniques. And I'm going to introduce something called a slice. And what a slice is that it lets us take a chunk of data within the data frame. So a slice is indicated by a colon like this. So I'm just going to run through an example so you can visualize this. So what this does is essentially it takes the first row, 0, so the row that Bulbasaur is in, and then in terms of columns, it'll take the first column all the way to the 9th column. I know it says 10 here, but just stick with me over here to the 9th column. So it'll print this row, and then it'll take the first column, so name, all the way until 2, 3, 4, 5, 6, 7, 8, 9, until special defense. So you'll see what I mean when I print this out. Yeah, so it took Bulbasaur, and then it printed every single value until special defense. And that's only possible through the slice, because as you can see here, took first column, and here it says 10, but the thing about a slice is that it's exclusive at the end, meaning it doesn't include this number here. It only includes up to this number minus 1, so 9. So that's just the thing about slices in using iloc. It's a little bit different using loc, but in iloc, the end is always exclusive. Okay, so just remember that. That's really important. So I just want to show this with you. If I do something like this, like if I put a slice over here, what this signifies is that I want to take everything. Since I don't specify a value for the beginning or the end, it essentially means that there's like no boundary, right? So if there's no boundary, it means print every single row, and for every single row, print out the columns from 1 to 9. So if I do that, it should print out, yeah, prints out all 800 rows, but it only prints out 9 columns. So yeah, that's how slicing works with iloc. With loc, it's a little bit different. So if I try something like this, just play around. Yeah, so if I try something like this, essentially it'll take, starts from the beginning. So it'll start from the first row and it'll go all the way up to the 5th row actually. And then for every single row, it'll print from the column name all the way to type 2. And if you haven't noticed, the thing that's different about loc and iloc is that for loc, the slice is actually inclusive. So notice how the label here is 4. Look what happens when I print it. 4 is actually included, so is type 2. If this was iloc, 4 would be excluded and it would only print up to 3, and it would only print up to type 1. So make sure you know these differences when you're using loc and iloc. Yeah. Okay, so that was slicing. Another thing that you should keep in mind, or not keep in mind, but you should know is booleans. Now, what booleans are, they're basically like true or false, essentially. And I'm going to show you an example right here. So let's say I'm going to use loc. Let's say I only want to print out the Pokemon that are legendary. So here's the code that does that, and I'm going to explain how it works. So here you can see this only prints out the Pokemon that are legendaries. So what this does, as we know, loc refers to our labels, right? So here I call the data frame, and what this does is that it goes into each row of the data frame, and then it checks if the legendary is true. So here, if it's labeled true. If this is true, then this whole statement will return true. And if this whole statement returns true, it will print the row. However, if it's false, if this statement prints false, that row won't be printed. And for those of you who are unfamiliar with Boolean operators, equals equals evaluates whether or not something is true, given the expression. There's also another operator, does not equal, or exclamation mark equal. This evaluates whether or not an expression does not equal something. So if I wanted to print out all the legendaries, all the Pokemon that aren't legendary, then I would use this expression. So yeah, so here, everything's false over here. So the logic behind this is that, okay, it goes into each row of this data frame, and it checks if it's legendary. And if it's not legendary, this statement will return true. And therefore, that's why we have all of these things. And then there's also operators like OR and basically how these work is just, if let's say if a, I'm just gonna type it, if a fruit is good or a chocolate is good. So I know this is kind of pseudocode, but to reason this out, if a fruit is good, so if you like fruits, if this is true, or if this is true, if you like chocolate, then this whole statement will return true. It doesn't even matter if this is false. As long as one of these statements is true, this whole statement will return true. But if you use something like and, so let's say you don't like chocolate, but you like fruits. So this will return true and this will return false. This whole statement will actually return false because an and requires both conditions to be true. And I know this example is kind of bad, but just bear with me over here. So that's just Boolean operators. So yeah, that's pretty cool. Moving on, we're going to move away from accessing data and we're going to move into sorting data, which can be really useful. So to sort data, we're going to use the method sort values. Very intuitive, right? So sort values has certain parameters. So the parameters it takes is, first of all, the column you want to sort. So let's say I want to sort the HP column, right? So I type in HP. And remember, when you're accessing locations within the data structure, you want to use square brackets. And if you're using a label, you want to use the quotation marks. And then I'm going to set ascending equals true, which means I want it to sort from least to greatest. And if I do that, you can see I have smallest to greatest. Wow, Shed Ninja really chilling out here with 1 HP. Pretty cool. Another thing you can do is you can set it to false. So if you want to see the greatest Pokemon, greatest HP Pokemon, you can do this. That's really cool. So yeah, that's how sort values essentially works. You can do it for any column. So let's just say I don't want to see HP anymore. I want to see total. And if I get that, you can see that. Oh, sorry. Yeah, you can see that Rayquaza has the largest, actually it's tied with Mewtwo. They have the largest total stats. And this is really useful for analysis sometimes if you just want to base their strengths off of certain data. Okay, so since we're done with sorting, we're going to move into math a little bit. So we're going to dive a little bit deeper into summing certain columns. So I'm just going to give you an example. Let's say we want to create our own column. Like, I just want to analyze something different. I don't want to analyze attack, defense. That's too boring. Let's analyze something called the power level. And let's define this power level as the combination of the Pokemon's attack and special attack. So this is the Pokemon's true power, let's just say, okay? And by doing this is what it does. It adds the columns together. So notice how Rayquaza has 180 attack and 180 special attack. If I do this, it'll create a new column called power level, and it'll have a total of 160, and it'll do the same thing for every single row. So that's essentially the math involved. You can also do minus, divide, multiply. I'm just going to do add for now, just to keep it simple. And if I print out df, you'll notice that I have power level right here. Cool. Yeah, so that's that. But you notice how it's at the very end? I kind of want it over here near the beginning so I can just see it better. Now to do this, you don't really have to memorize or know this code essentially, but what I'm going to do is I'm going to make a variable name called columns. And I'm going to store a list of the data frames columns, meaning all of these columns, so pound, name, type 1, whatever, I'm going to store it into this variable here. And then I'm going to use our data frame variable, and I'm just going to rearrange the columns. So I'm going to take the first 3 columns, so 0, 1, 2, 3, right? And then I'm going to add the last column we have over here. The last column is 13. So we have 14 columns. And we know since the columns start at 0 rather than 1, the last column is denoted with 13, which is our power level. So it goes, so from here we go 0, 1, 2, 3. Then I want to add the last column, so I'm putting it right here. And then I'm gonna shift everything to the left. So now I'm just adding all of these columns back, right? So I took the first three, 0, 1, 2, 3, added in power level, then I added in the rest of them back. So that's what this does. And if I print df, boom, we got our power level over here. So great, now we have our power level. How do we analyze this? Let's just say I want to see which Pokemon has the largest power level. And based off of that, I'll declare them as the strongest Pokemon. So if I do something like this, set ascending equals to false because I want to see the strongest or the greatest power level. Oh, error, what did I do wrong here? Let's just double check. So it says ascending. I spelled ascending wrong. Yeah, so make sure you're spelling everything correct. If you just get an error, just look at like the last line and it should tell you what's wrong with it. Cool. So you can see, Pokemon with the greatest attack or power level is Deoxys attack form. Okay, I see. It's pretty nice. So yeah, that's basically how you can manipulate the data that you have currently and just create your own data and analyze that. So one other thing that you guys should know is how to drop certain data values. So for example, let's say I was just doing an analysis on like the types of Pokemon, like, this Pokemon's a dragon type or psychic type, and let's just say I just don't care about any of these stats. I could drop all of these columns over here. Like I could just delete them from the data frame. And how you would delete stuff from the data frame is you would do something like this. So you'll call the drop function or method, and you want to specify the columns you want to drop. So over here, for every row, so this denotes every row because we're using a slice over here, I want to drop everything from rows 5 to 14. So it goes columns 5 to 14. So it goes 0, 1, 2, 3, 4, 5. So let's just say I want to drop everything from total to legendary. So this specifies that. Then for drop, there's a parameter called axis. And what axis does is it specifies whether you want to drop the rows or columns. Axis equals 1 specifies columns. Axis equals 0 specifies rows. Since we want to drop columns, I'm setting it to 1. Now, there's also another parameter called inPlace, and we're going to set this to true. Now, what inPlace does, the effects of it, if you set it to true, you won't have to do something like this. Because usually if you just apply this df.drop, it'll drop all of the columns, but it won't actually change the structure of your data frame. This is just like a temporary change. But if you set inPlace equal to true, this will permanently change your data structure or your data frame. But if it's false, it's just temporary. So since I set it to true, it's permanent. And then if I print my data frame, there we go. Half of the columns have been deleted. And this is really how you can simplify your data frame. And once you've done this, let's say you're just happy with your data frame and you're just like, you know what, I just want to save this so I can refer to it next time. You can actually write or create your own CSV file and save it. So if I run this, there should be a new file that pops up. Yeah, so there we go. You get a new CSV file, and you can also do the same for Excel. It's like the same thing. And yeah, so this is basically your introduction to Pandas. And now we can actually get into the exciting stuff, and we can apply this to the COVID-19 dataset. So now we can actually start coding our project for the COVID-19 dataset. So to get started, You just want to click new Python file, name it whatever you want. I called it COVID-19. And before we actually start coding, you want to make sure you have these two data sets in your file, so confirmed and deaths. I'll have these data sets linked within the video description. And essentially what the confirmed data set has is the total amount of confirmed cases globally to April 1st, and the same thing with deaths. And this is a relatively simple data set, but there's more complex ones if you want to see them online. So for example, this one's called Novel Coronavirus 2019 dataset on Kaggle. It's not actually 2019, it's updated every 24 hours. And here you can play around with several different variables. Dude, you have the reporting date, the summary, the location, country, gender, when the symptom was onset, hospital visit date, all of these variables is insane. And you can really use this to analyze the virus pretty well. And in other cases, there's this guy who performed a really deep analysis on corona with this data set, and he created really, really cool things such as visualizations. Over here, he just highlighted those that are high in confirmed cases or high in deaths, for example. There's other examples where he graphs out everything, puts into stats, and this is really what we want to achieve in our project as well. So going back, an additional thing that we're going to put other than import pandas is to import something called matplot. And what matplot is that it's a Python library that lets you graph the data that you've created. So kind of like the stuff I showed you before where the guy had graphs of, the greatest amount of deaths with corona or whatnot. So first thing we're going to do is we're going to load into deaths. So we're going to store it in a df deaths variable, read CSV, and deaths.csv. So we're just going to see what this looks like. Cool. Okay. I'm going to run it. So make sure this says run whatever file name you were using, because sometimes it might run the Pokemon file by accident. So here you can see that we have 256 rows and 75 columns. And yeah, the columns basically state the amount of, the amount of deaths per day. And I want to see all of the columns. So I'm just going to take the code from our Pokemon dataset and make it show 13 columns. I don't need to see all of them. I just want to see some of them. And here, yeah, we were missing the latitude and longitude values for the countries and then more dates. Okay, so one thing that I noticed from this is latitude and longitude, I don't really care about those two values, so I'm going to drop them. And yeah, so the main thing I want to do with this data set is to create a death rate, essentially, so that we can analyze it and see which country or place would be more safe. And actually, since I'm Canadian, I want to narrow this down to Canada and see which province has the highest or lowest death rate. So that's our goal. Let's see if our latitude and longitude were dropped. Ooh, error. What did I do wrong? Let's see. Unexpected keyword argument columns. My bad. I'm supposed to say columns. Missed an S. There we go. Latitude, longitude, gone. Okay. So now that that's gone, I want to find the total amount of deaths per country, because that's how I can get a death rate. So I'm going to make a column called total deaths. And to get that, I need to sum each column within the row. So I need to add 4 by 4 by 4 by 4. You get what I mean? So to do that, I'm going to have to call this method called sum. And what sum does is that it sums everything within either the column or the row. And to specify which one it does, use this axis parameter and you say 1. You do 1 to sum within the columns of each row. So in this case, it would sum 4 plus 4 plus 4 plus 4. But if you did axis equals 0, it would do 4 plus 8 plus 26. So yeah, that's the logistics behind that. So if I do this, you'll see that total deaths will appear over here, and it'll sum up all the values within these columns. So now that I have total deaths, all of these dates are kind of redundant, and we don't really need them. So let's drop it. So we're going to drop it, df deaths, iloc. So logistics behind this, for every row in our data structure or data frame, we're going to go from the second column, so 0, 1, 2, so where the dates start, all the way to the 72nd column, because this is exclusive, right? So we have 74 columns, and since we know that our columns start at 0, this is 73, and this is 72, and this is where we want to stop. So that's why we have it end as 73. Now we're going to set our axis equal to 1, because we want to drop columns rather than rows. In place equals true, because we just don't want to write the additional equal statement. And if we print this, all of our dates should be gone. Boom. Perfect. We got it. Okay. So now that's good. I just want to try something. Let's analyze this a little bit before we start creating the death rate. So I want to sort the values, and I want to see which countries have the greatest deaths. And according to the news, it sounds like Italy and China, but I'm not too sure. Let's actually check it out. So let's sort it by the total deaths. In place equals true. Ascending equals false, because we want greatest to least. And if I do this, let's see what we get. We get China has the greatest, then Italy. Yeah, okay, so it sounds about right. Okay, so actually with this data set, I want to graph it. I want to show you guys how to graph using Matplot. And I don't want to graph everything. Like, that's 256 countries. I don't think that's doable. So I'm only going to graph the first 4 rows. And to do that, we're going to have to use head. So head 4, that gets the first 4. And we're going to use .plot, which comes from the matplot. And .bar to make it a bar graph. And in the parameters, we're going to specify the labels. So in the x-axis, we want our labels to be the country/region. So this. And in our y-axis, we want our labels to be the total amount of deaths. So this. And then we just have to add one more thing, plot.show. This will essentially make sure the graph would show up when we run our program. So let's run it. Ooh, error. Okay, why do we have an error? Let's see. Ooh, I forgot the y in country. There we go. Yeah, spelling mistakes get you nowhere in programming. Okay, so here, as you can see, our graph looks pretty standard. And yeah, it looks like China and Italy really have a lot more, or exponentially more than the rest of the world. So yeah, it's pretty nice to visualize. It gives you a really good representation of the amount of deaths that these countries have. So that's really how you graph. We're not going to use it anymore, but if you're really interested in data visualization, you should really look into Matplot. It's really cool. So I'm just gonna delete this. Sorry, yeah, we don't really need it, it's fine. Okay, so moving on, we're gonna load in our confirmed cases because we want to start making our death rate. Equals pd.read csv confirmed.csv. Great, we've loaded it in. Let's check it out. What does it look like? Don't need this anymore. And what this looks like is basically the same thing. Of course, we're going to have greater numbers because it's easier to catch corona than die from corona. So, yeah. As you can see, latitude and longitude, we don't care about them. I'm just going to copy and paste some of the code. We're dropping it. We don't need it. Okay, I don't need to print that. We already know that's going to be dropped because it worked before. we're going to make a new column called total confirmed cases, because that's how we're going to make our death rate. We're going to divide our amount of deaths by the confirmed cases. And confirmed sum axis, cool. That should create a new row. And then we want to drop all of the dates because it's going to be redundant after making that total confirmed cases column. So dropping it. Okay, now we're going to print it to see if everything worked. There we go. Everything did not work. Hold up. Wrong thing. Should have been confirmed. There we go. This should work now. Perfect. Now we have the total confirmed cases. Now that we have all of this, as I said, I wanted to go more into Canada rather than worldwide, just to make this easier. So to do that, we're going to go back to our Boolean. So remember, for the Pokemon dataset, we made the data frame only display Pokemon that were legendary. So now we only want this data frame to display countries, or actually no, provinces from Canada. So to do that, we're just going to do something like this. df confirmed equals. I'm not going to run through the logistics of this because we've done this already. This equals Canada. Ooh, what did I do there? My bad. Ooh, I don't know how to type today, huh? Okay, perfect. Let's just double check if this works. And yeah, there we go. We have all of the Canadian data here. As you notice, there's actually cruise lines over here because they were a big part of this Corona case. And we're going to do the same thing for deaths. Why am I even typing it? I can just copy and paste. Here we go. Deaths. Deaths and deaths. Cool. Now we have all of that settled down. Now we want to combine both of these data sets into one. So before I do that, I just want to show you what the deaths look like. Yeah, there we go. So deaths look like this. So I want to combine both of these data frames so I get like a total deaths column, and I also get like a total confirmed cases column, and then I can start making my death rate. So to do that, I'm going to use something called a concatenator, and that concatenate basically means to combine. So I'm going to do something like this, make a new variable df, and I'm going to call the Python library Pandas, and call the concat method, and combine my deaths with my confirmed cases like this. This is essentially what it means. It means to combine my data frame of deaths and confirmed cases together. Now, I want to combine them vertically, meaning like I want to put them side by side rather than like on top of each other horizontally. So it'll be total deaths and then total confirmed cases rather than total deaths and then total confirmed cases at the bottom. And notice how both data frames have province, state, country, region. Because they're duplicates, concatenate will take into account for that and just keep it here, and they won't add like duplicate versions of it. So yeah, that's pretty cool. So let's just see if this works. Print df. Perfect. Yeah, so, oh, I lied. My bad. Concatenate does not account for it. So what we're going to have to do is we're going to have to delete the provinces and states. So we're going to have to drop them. So we're going to have to drop it from confirmed. So let's just copy and paste it. Okay, for every row, we want to drop the So this would be the first, 0, 1. We'll have to drop the first column and the second and the first column. No, the first column and the second column, yeah. Country region, key error, country region. Okay, here. My bad. There we go. Perfect. Yeah, the reason why I didn't work here was because this was, when I was over here, it was before I got everything to Canada, before all the data sets were in reference to Canada. So that's why it didn't work, because the elements were, or the indices were a little bit off. So yeah. Okay, so now I have the total deaths and total confirmed cases. We can start making our death rate. And to do that, we want to create our death rate column, death rate, and I'm going to put in percentages. And here's where the math comes in. So we're going to do df total deaths divided by df total confirmed cases, and we want this in a percentage. So we're going to multiply by 100. And when we do this, there we go, we get our percentages. So as you can see, actually no, let's sort this. Let's make use of the stuff that we learned today. So we're going to sort it, and we're going to sort it from greatest to least, because I want to see the country or the province with the highest death rates. Death rates. Percentage, place equals true, sending equals false. Print df. Cool. All right, it looks like, okay, I'm going to explain why this is like this later on. Okay, but here you can see British Columbia has a death rate of 2%, which is pretty high in comparison to everywhere else. Ontario has a 1.3% death rate. And yeah, wow. So it looks like if you live in the highly populated areas such as British Columbia or Ontario, there's a higher chance of you dying from corona. But if you actually live in like the outskirts, where you have Nova Scotia, New Brunswick, Yukon, it turns out you'll be just fine. Yeah, and actually no, I thought some of them had no confirmed cases, but they do. Okay. Yeah, so one thing I want to show you guys is Pandas is always subject to error, especially when your data set's really large like this one. Actually, this isn't that big, but it's still a decent amount. Diamond Princess, as you can see, had a total deaths of 11, but confirmed cases of 0, which doesn't make sense. And the reason why it's 0 over here is because when Pandas was like reading the file, it read it wrong. And the thing is, you can't really fix this issue unless you manually go into the data and sort out the commas, because this was separated by commas, and the interpreter or Pandas read the commas wrong. And this is always subject to happen when your data set's just this big. So these are the kind of errors that you're just gonna have to take in. Like it's just bound to happen. So yeah, that's one thing. I believe this was also an error as well. So yeah, there's just one thing to take out of Pandas, and hopefully you guys learned something from creating this. And if you weren't able to code everything, that's fine. I'll have everything posted in a link to my GitHub in the video description. So yeah, if you missed out on anything, that's cool. So yeah, hopefully you like this video. If you have any suggestions or any feedback, feel free to just comment below, and I'll try to work on it. All right, have a good day.